Hey everyone, and welcome to today's Explainer. If you're aiming to build modern AI backends, or honestly just any high-performance application, you are in exactly the right place. Today, we're unpacking a really high-stakes topic pulled directly from the FastAPI concurrency 7-day production blueprint. We're zeroing right in on day one, the async event loop. So let's dive into this, because before you ever touch a web framework, before you write a single line of FastAPI routing, you absolutely have to master the foundational mechanics of Python concurrency. It's basically the secret engine of modern web performance. All right, day one, the foundation. Let's get into the core mechanics you need before writing a single line of web framework code. To really get why this foundational knowledge is just absolutely critical, let's picture a bit of a nightmare scenario. Imagine you've built this brilliant AI feature, right? You've got your endpoint set up, it works perfectly on your local machine, and you're feeling great about it. But the moment you deployed it to production and multiple users hit your API at the exact same time, everything just stops. The API becomes completely unresponsive. So I've got to ask you, why do future AI endpoints freeze under load? What exactly is causing this massive, catastrophic traffic jam in your code? Well, the answer is a pretty stark reality for a lot of developers, and it's something you have to confront right now. It's because you blocked the async event loop. This is sort of the hidden mechanic, the invisible traffic cop inside your application. When you block it, you're essentially parking a massive, immovable truck right across a one-lane highway. The traffic backs up, the server hangs, and literally not a single new request can get through. It's just a total system gridlock. So what is this thing? The asynchronous event loop is Python's native, built-in mechanism for handling concurrency. Think of it as your absolute day one foundation. Before you go introducing frameworks like FastAPI, which, as the documentation points out, achieves its massive performance by standing on the shoulders of async giants like Starlet, you have to understand this native Python loop. It's the engine that lets your application juggle multiple tasks, seemingly all at the exact same time. It manages who gets to use the server's attention and exactly when they get it. Moving on to a really crucial distinction, I/O versus CPU-bound operations. Let's break these down. The whole key here is understanding this exact comparison. On one side, we have I/O-bound operations. I/O just stands for input-output. This is when your code is, it's just waiting. It's waiting for a database query to return, or maybe waiting for a network request to some external LLM API to finish generating text. During this waiting time, your server's processor isn't actually doing any heavy computation. It's literally just listening for a response. Now, on the other side, we have CPU-bound operations. This is the heavy lifting. We're talking about complex math, heavy text chunking algorithms for vector databases, or running machine learning models inline. If you take a heavy CPU-bound task and drop it smack in the middle of your async event loop, it forces the loop to just stop managing everything else and do that heavy math. And that naturally leads us right to the golden rule of async Python. Never block the event loop. Seriously, this is high-stakes mentorship straight from our source blueprint. It is the absolute, unbreakable golden rule. Every single time you write an endpoint, you need to ask yourself, am I blocking the loop right now? If you remember literally nothing else from today's explainer, etch this phrase into your brain. Let's detail exactly what hits the fan if you ignore this rule and block the loop with a heavy task. The consequences are, frankly, fatal for a production application. First off, your AI endpoints freeze under load. Because the event loop is stuck grinding through some massive machine learning task or maybe heavy text chunking inline, it physically cannot accept new connections. And that means no other users can access the API. You could have 100 people trying to use your app, and they will all just sit there staring at a spinning loading wheel. The entire system basically collapses because that one single heavy task has completely hijacked the single thread of the event loop. All right, let's get into simulating concurrent fetching. It is time for a quick exercise to get this into your muscle memory. Here is your exact day one action plan and homework to really master the core mechanics of Python's concurrency. First up, the blueprint actually advises you to go search YouTube for ArjanCodes Async Python and watch his core explanation. According to the open source AI engineering master plan, this channel is an absolute free gold mine for understanding advanced Python architecture. So go watch that video to grasp the underlying theory. Then step 2, you need to write a pure Python script. Don't even touch FastAPI yet. You're going to use a specific native Python function called async.gather. And the magic number for that pure Python script is 3. You want to write a script that simulates fetching exactly 3 different web pages concurrently. By using asyncio.gathering, you're basically instructing the event loop to start fetching page 1, page 2, and page 3 all at the exact same time. And because fetching a web page is an IO-bound task, remember, you're just waiting on the network, the event loop can effortlessly juggle all three of those requests without freezing your application. It proves you know how to manage that waiting time efficiently. Mastering this pure Python async behavior is honestly the only way you'll be able to successfully leverage those powerful tools later on, which leaves us with a critical, kind of provocative question to wrap up on. Is your event loop ready for Fast API? Tomorrow's content in the blueprint moves straight into the framework, utilizing Pydantic for strict data typing and building out actual API routes. But you're only going to succeed there if you've respected the golden rule we learned today. So take the time, simulate those 3 concurrent fetches, and make sure your foundation is rock solid. Thanks so much for joining me for this explainer, and keep building.